Thanks for viewing my talk. I'm going to be presenting results examining how urinary cortisol patterns can reveal flexibility in developmental processes in wild apes. Throughout the animal kingdom, development can take many forms in terms of duration and the level of dependency on parental care. Regardless of variation in forms of development, ontogeny is associated with high sensitivity to the environment. This sensitivity is important for developmental plasticity, in which organisms optimize adult phenotypes to suit environmental conditions. For long-lived species and those with a long postnatal juvenile phase, this means a longer and maybe more accurate optimization to the environment, which can be adaptive. However, if the developmental phase is also associated with parental care, having an extended ontogeny can lead to sustained parent-offspring conflict for resources. The hypothalamic pituitary adrenal axis is one of the principal mechanisms by which vertebrates respond to stressors. It stimulates the release of glucocorticoids such as cortisol into organs and tissue, in turn stimulating the production of energy for the behavioral or physiological response to address the stressor. There are many studies mapping glucocorticoid levels across ontogeny. However, the developmental literature currently lacks interspecies or interpopulation analyses to fully explore the extent to which ontogenetic cortisol patterns are stereotypic within a species, or whether there is a lot of plasticity to socio-ecology. To address this, we performed a study looking at HPA activity across ontogeny in young chimpanzees and bonobos. These closely related apes live in multi-male, multi-female groups with high fission-fusion dynamics. However, they have very different socio-ecological settings. Bonobos tend to be more gregarious than chimps, and this is likely because of reduced feeding competition and more consistent resources in bonobos compared to chimpanzees. Related to this, intra- and intergroup violence in bonobos is typically low in intensity, whereas growing up as a chimpanzee can be difficult, with higher risks of infanticide when very young, but also with a greater risk of violence generally during development. However, this caricature of chimpanzees isn't true across all populations, and we know that population density, the number of individuals per kilometre squared, affects factors such as feeding competition and rates of violence. So our key question was whether these socio-ecological differences would lead to different ontogenetic patterns between these closely related species, and whether socio-ecology exaggerates or reduces stress related to parent-offspring conflict, such as during weaning. Our dataset included a mix of longitudinal and cross-sectional sampling dating back 20 years. In total, we had around 1,400 urinary cortisol concentrations calculated from 127 young chimps and bonobos. The Bonobo Dataset came from the Louis Catal bonobos living in DRC with a population density of 1.3 individuals per kilometre squared. For the chimpanzees, we had samples from one low-density chimpanzee population, the Thai chimps in Côte d'Ivoire, with a similar population density to our bonobos, but also from one high-density chimpanzee population, the Bodongo chimps in Uganda, where the chimpanzees live in a density more than 4 times that of Thai chimps or Louis Catal bonobos. So to our results, we found a significant effect of the interaction between population and age on urinary cortisol concentrations. When we look at bonobos and our low population density chimpanzees, cortisol is quite consistent across ontogeny. However, when we look at cortisol patterns in the high population density chimpanzees, we see quite a lot of variation across development. All in all, this was a bit of a surprise to us because we found greater differences between populations than between the species. We found no support for weaning-related stress driving these differences. Instead, our high-density chimpanzee cortisol pattern is similar to that seen in another high-density chimpanzee population in a study by Chris Sabi and colleagues, the results of which are illustrated below. In both of these high-density populations, we know that females with young offspring use strategies of male avoidance and reduced gregariousness to cope with feeding competition and the threat of violence, which might explain declining cortisol levels early in ontogeny in these chimps. In comparison, in bonobos, or our low-density chimpanzee population, maternal gregariousness is consistent regardless of offspring age, meaning a consistent social exposure and stress level for their offspring. These results imply plasticity in rearing strategies might have quite profound effects on developmental physiology, but we clearly need more data on maternal strategies to make a direct link to cortisol levels in their offspring. If you want to know more, this study should be out soon in the Journal of Human Evolution. And with that, I'd like to thank people who worked on this study and you for watching. Thanks.